Hi Year 7, hope you're all well and having a lovely week. Welcome to your first maths lesson of the week. Today we're going to do prime factorisation and the date is the 20th of January, so if you want to just pause the video quickly now and make sure you've got that date and title in your exercise books or wherever you're working. Okay, so I'm going to go through a couple of examples with you. The first one I'm going to encourage you just to watch along and copy in, and then the second one I'm going to encourage you to have a bit of a go yourself. So this first one, if you've got your yellow notes book, that would be the best place to put this, and you might put a couple of little bullet point instructions in there, but the main thing is that this example is in your yellow notes book. If you don't have your yellow notes book, then you just have to note it down wherever you're working. So we've been asked to write 72 as a product of its prime factors. Now, what we're doing today can come under lots of, well, not lots, but a few different names. Okay, but the key point for all of the names is it mentions prime and factors. And the prime factors are kind of like the factor building blocks for any number. Any integer has its own unique factor building blocks that make up that number, and if we finding those factor building blocks can help us do lots of different things and understand how that number is made up better. So it's a really useful skill, and it's not a particularly difficult one either. It's quite a satisfying one, I think. So we need to basically break 72 down into factors until it can't be broken down anymore. So the way we're going to start doing that is we're going to take our 72, I'm going to put it in a little box, and we're going to draw something called a factor tree. And so the first thing I'm going to do is put two branches like this, and I need a factor pair of 72, and it can be any factor pair of 72 apart from 1 and 72, because 1 and 72 isn't very useful because it doesn't break it down. So I'm going to start with 8 and 9. Now remember, what I'm looking for are prime factors. Now 8 isn't a prime number because I know that it's got more factors than just 1 in itself. 9 isn't a prime number because I know it's got more than 2 factors. So I need to break both of these numbers down more. So 8 I'm going to break down. I know that 8 can be broken down into a factor pair of 2 and 4. Now again, I'm after prime factors, and 2 only has 2 factors, so it's prime. So I'm going to circle that. My prime factors are the important ones I'm after, so I circle them so they sort of stand out really clearly to me. But 4 isn't prime. 4 can be broken down more, so I'm better break it down more, and 4 can be broken down into the factor pair of 2 and 2. And again, we know that 2 is prime, so I'm going to circle those as my important prime factors, the ones that I'm looking for. And then that just leaves me with that 9 that I haven't broken down yet. 9 isn't prime. It can be broken down into 3 and 3, because 3 times 3 is 9. And 3 is a prime number, which means it is a prime factor, so I'm going to circle those 3's. As ever, do pause this video if you're making a note of this to make sure you can get it in. Don't feel like you need to, you need to watch the whole video through at once, pause it, skip back as much as you need to. So that's my factor tree done. That's pretty much the bulk of the work done. The last thing is just to write 72 as a product of its prime factors. So remember that word product. You've come across that once or twice before. Product means things being multiplied together to make something. So what I'm going to do is take all my prime factors and write them being multiplied together, because that should give me 72. Really important though, I count each one individually if they double up, because otherwise that will give me a different number. So I've got 2, 2 and 2, so 72 equals 2 times 2 times 2, and I've got a 3 and a 3 times 3 times 3. And if we do this right, we should notice that all of these numbers are prime, which they are, and that if I do the multiplication, 2 times 2 equals 4, times 2 equals 8, times 3 equals 24, times 3 equals 72, it gives me the number I was looking for. So if all of those numbers are prime and they multiply to give me the number I was looking to break down, then that means I can be confident I've done it right. The only other little trick we do sometimes is we write it in something called index form, which makes it a bit neater. We have come across indices briefly. 2 times 2 times 2 is the same as saying 2 cubed, and 3 times 3 is the same as saying 3 squared. So sometimes you just write it in index form because that can be a bit neater. Do pause the video if you just need to finish copying that example down, and then we're going to do one more together on the video today before I let you get on with the task. The other one we're going to do is we're going to find the prime factor decomposition of 120. Now, like I said before, slightly different way of wording it this time. Prime factor decomposition. You might recognise that word from elsewhere, and you might have to think about what it means. But the key point is we've been asked. Oh, sorry about that. Autofocus has gone slightly down. I'm sure it'll come back. We've been asked for prime factors. Okay, and whenever we're asked for prime factors, this is what we need to do. So have a go at this one now, and then if you're struggling, you might just unpause the video and just watch the first little bit, or if you're confident, you might do the whole thing and watch the video back. Okay, so I'm going to have a go at this now. So I'm going to take my 120, I'm going to put it in a box. Now, for those of you that have done this whole thing, or maybe made a start of it, it's important to note there are lots of different ways of breaking down 120 that are all correct. Okay, so I'm going to break it down one way. You might have broken it down a different way. That doesn't mean that yours is wrong necessarily. Okay, so you might have started with 2 and 60 or 3 and 40. Where they've got a factor of 10, I like to start with the factor of 10 because I think that's quite an easy way to break it down. So I'm going to start with 10 and 10 and 12. But there are other ways you could have started that. Neither 10 or 12 are prime, so I'm going to break them down more. 10 can be broken down to 2 and 5. 2 and 5 are both prime, so I'm going to circle them. 12, a couple of different ways that 12 can be broken down again. I'm going to break them down into 3 and 4. Now 3 is prime, so I'm going to circle that. But 4 isn't prime, so I need to break it down more. And 4 can be broken down into 2 and 2, which 2 is prime, so I'm going to circle those 2's. And the last thing to do is write my final answer. Write 120 as a product of its prime factors. So 120 equals, again, making sure I don't miss any off, 2 times 2 times 2 times 3 times 5. And note that I'm doing them in order. It's not really bad or incorrect if you don't do them in order, but it is quite a standard thing we do to do it in order because it just makes it a bit easier and a bit clearer. And if I wanted to write that in index form, I know that 2 times 2 times 2 can be written as 2 cubed, and not missing the times 3 times 5. So I hope that all makes sense. Have a go at that task now, and as ever, any problems, just drop me a quick email. Have a lovely day.